target for the day, what we're going to be focusing on, knowing and understanding by the end of our 30 minutes together or so, is making sense of a contextual problem involving fractions. Turn and talk to your neighbor. What's a contextual problem? What's that mean? Context clues. So where do you use context clues? In a what? In a story, right? So what kind of problems do you think we're solving? Let's come back together. And our friend, it's not Leah, tell me your name. Jackson. Tell us what you think we're solving today, making sense of, I should say. What are we making sense of?
Contextual.
Contextual problems, what is that?
We're figuring out the problem in a story.
Like a story problem, right? He said it's like context or context clues, a story problem. So it's just a fancy word for word problems or story problems. So you're going to make sense of these fractional problems. So making sense of it, meaning you're going to be using words like parts and wholes and explaining how you know what to do. So those kinds of words I should be hearing you talk about as you're talking to your group, okay? Parts and wholes. Your success criteria is you'll know you've mastered it when you can model the problem and explain the model. So as I'm walking around, remember, because we're making sense of it, I need you to model it and make sense of what's happening in the problem. Are you with me? All right, here we go. So, Josie and Margot, they're painting a fence. See that fence? Yeah, sounds like fun. Do y'all like to paint? No, me either. I hate it. It makes my shoulders hurt. Who likes to paint?
I know that.
Oh, good. Some of you like to paint. I'll hire you out when I need some painting done around my house, right? So I don't like to paint so much, but Josie and Margot, they're painting this fence. And they're painting it green. Josie starts at one end, and she's painting 3/10 of the fence. Margot starts at the other end and paints 4/10 of it. What fraction of the fence do they paint? So some of you are like, I know the answer already. But remember, our learning target for the day is to make sense of the problem and what's happening. So I have a little bit of a challenge for you. I want you to talk with your partner using the words, without using numbers. I want you to talk about how you would solve this problem with your partner without using numbers, okay? We'll kind of have a pause minute where we come back and talk about that as you're exploring. So talk with your partner about what you would do. Use the words parts and wholes if you need to, and without using numbers, how you would solve the problem, okay? And then I'm going to let you model that problem with those popsicle sticks that you have in front of you so you can make sense of this problem. So as I come around, I'll be asking you to tell me, how would you solve this problem without using numbers? So you can't say, I took 7 plus 3 and I got 10.
But could you?
You would have to say something else, right, to tell me how to solve the problem. So you can't talk about numbers. You can only talk about words on explaining how. Then when we model it, we can write our equations in words. Equations and write our words there, okay? So I'm going to set my timer, and I want you to get started with your partner. You can use the popsicle sticks. First thing I want you to think about is, how would you solve this problem? What do you think you need to do and why? Okay? Turn it to the page to find the total.
We're not going to do that.
So if you were going to tell me how to solve the problem without using numbers, what would you tell me to do? What do y'all think? Y'all all can talk if you want. What do you think? You're adding. Okay, so what would you add? Can't say numbers. Oh, I need a buzzer. It goes and. So you can't use numbers. So you said you would add. What would you add? Okay, but from the problem, you were going to say you were going to add what? Did you hear what he said? No. Each part of the fence that they painted, and you would get the what? The total what? That they painted. So I wonder if you can model that and maybe show that in an equation, what that equation looked like. So thinking about your model here, what do these represent? So how much did, and you can use numbers now because you've solved it without it. So how much did Josie get? Josie?
And Josie.
What did Josie do? Josie did.
Oh.
Oh, yeah. No, Josie did how much? 3 tenths. So I see 3. How do I know they're 10?
10 parts. Yeah, because it says the numerator, the denominator is 10.
Okay, the denominator's 10. So that tells you there's how many what?
There's 10 parts, so just have 10 separate.
Oh, so let me ask you a question. We all work together as a big group here since y'all are kind of talking already. How could we show the whole fence before it was painted? Talk to your group about that. What would that be? All right, guys. Tell me what's going on in your mom. Oh, so you took away what? Oh, he's the number.
No, we took away part of the fence. I mean, we painted part of the fence.
Okay. Okay, so you painted part of the fence. Who painted part of the fence? Margot painted part of the fence. And who else painted part of the fence? And so what'd you do with those 2?
We added them.
Oh, how'd you do that?
Because don't say the number, Josie. I know. I was not my son has nothing to do with the number.
So you said that they added.
Because it's saying that like they're painting like one at a time. So that's how I knew they were adding because they're painting away.
Okay, so when we add things, what do we do to them?
We paint both of the numbers.
Both of the numbers. I want you to use the words parts and wholes. What do you do?
We take two of the parts and then add them together.
So what I'm wondering is, could you write an equation or a part whole, number 1, to show me what are the parts and what are the holes? Yeah, work with that. Show me, but label it and tell me what's the parts and what's the holes. Y'all work together on that, and then I'll come back to you in just a second. All right, talk to me about your models here that you got going on. Let's look. Wait, hold on a minute. Let's look at this model. Let's look at this model. Something's up. They look different. What's different about them?
There's a different way. It's the same thing, but we're different.
Oh, so why do you think they chose to do theirs this way and you put yours this way?
They're representing what they're doing.
What do you mean?
They're representing how much Josie did and they're representing how much Margaret did.
So looking at their model, where is Josie's?
Okay. The 3, the first one.
Okay, so the 3.
And then they still have the 1.
Oh, why do you think they did that?
Because they had to add those 2 fractions to get their answer. So they still have the 11 plus how much they have painted. We have to add together. That's part of adding together the numerals. I was thinking something like that, but then Jackson did
and then like combining these and like counting them.
You'll put them back together like it was. So they are modeling what happened in the problem, because what happened in the problem with Josie and Margot is they did what?
they could do it painted one side of the fence and then
Yeah.
Margaret, you painted the other side.
So let me ask y'all both a question. Why do you have these extra ones here?
These represent what they did.
What they didn't paint. Oh, I think I'm following you. So, how many total sticks do you have?
Yes.
10. Why do you have 10?
Because that's the whole.
So the whole is 10. So tell me why you decided, so how did you solve the problem?
By taking away these and combining these together, count how much they have, and the rest of it.
Okay.
How much they did do and how much they didn't do.
So if I were asking you what operation you performed, what operation did you do?
We subtracted.
You subtracted?
Then at the very end, we had to add.
Oh.
Because we had to get what our total was.
Okay, so you're saying that you put the whole fence out, and then what did you subtract?
We subtracted the
3. We subtracted 3 from
So how did you know to subtract 3?
because it shows it tells you that you know 3 plus 4 equals 7, and the whole is 10, and you know you got 3 more.
Okay, so I think I'm following you. You said, so I knew 3 tenths and 4 tenths, right? And you had your 7. And then you had to think about, well, how many more to get the whole? So you kind of subtracted. or you counted up to get to that hole? So you knew there were three?
We added.
You solved the problem. Here's what I'm wondering. You remember my first challenge? How could you explain how to solve the problem without using numbers? If I said, tell me how to solve this problem without using numbers, what would you tell me to do?
You can subtract the parts.
We can take one.
So you could just subtract the parts and say how many there was.
So what am I subtracting the parts from? What are the parts and what am I subtracting it from? The whole is how much?
Okay, you add
10 what? Could you show me that in an equation, what you're doing there? That you have that, one of y'all, both of y'all? So she's saying you subtract the parts from the whole. So what were the parts and the whole in this? Remember, we're not using numbers. So y'all are saying parts and wholes, but from the problem, what was the whole? She took what? Y'all say numbers. We took out. Who was in the problem? Who's our characters in this problem?
Josie and Martin.
So we took out Josie's.
We took out Josie's amount.
Okay, and then we took out.
Added those up.
Right. So and you subtracted those from. You said the whole. But what's the whole in this problem? 10/10. But don't use numbers. What's the whole in this problem if I can't say 10/10? What's the whole in this problem? Yeah, one whole what? What's up here? What are we? One whole. We have our parts that Josie. You said I took the part Josie painted, and I took the part Margot painted, and I put them together, and then I subtracted them from the one whole what? What are we painting?
The whole fence.
The whole fence, right? So a whole is your fence, right? Great. So see, we can work that out in an equation there and show that what that looks like. My goodness, are you building a whole fence over here? What's going on? So talk to me about what's going on here. What's
Okay, so I did the fraction, and then you would keep the denominators the same, and then you would only add the numerators, and then the denominators would stay the same, and whatever the numerators.
okay? So your numerators are telling you what? How many you have shaded in, how many pieces they're painting, whatever, right? And so you're putting those together. So if you were not using numbers to solve this, to tell me how to solve this problem, what would you tell me to do? What operation did you use? Adding. So tell me what to add.
You could add.
Can't say numbers. I'm getting a buzzer. So what did you add together? What does this represent? This is a fraction that you represent. What fraction is this? You can say the number right now, 3/10, right? But what does that 3/10 represent? Who?
The tens.
How many who's? So we took the amount that Josie had, and what did you do to it? To the, got about 2 more minutes.
And then you added the marker.
Oh, did you hear what she said? So I took Josie's amount of painted fence and I added to Margot's amount of painted fence. And what's my total? And so what's our whole? Oh, but wait a minute. I thought you just said it was 7/10. Can you show me that in equation real quick with numbers? You can use numbers there. Can you show me what you just said in an equation? The 3/10 and the 4/10. So what are the parts here in this expression you've modeled out so beautifully? What are our parts? If you were going to use the words parts and wholes to explain this equation, what are the parts, what are the wholes?
3, 4, 5, 6, 7, 8, 9, 10, 11.
So what do you think about that? What do you think, ladies? Can you help them out? What are the parts?
So you take Josie's amount and add it to the
You took Josie's amount and added to Margot's amount. So when you're adding things, you're putting them what? Together. So when we have parts and wholes, what's the relationship? What do we do? What do you do with parts and wholes? What do you do with parts? Together, right? So you take the part, and you take the part, and you put them together, right? So in this equation, what are the parts?
parts are
And so that gives us the whole of what? 7/10. tenths. So we have our part, could you label that part, and whole for me, since we just talked about that? But here's what I'm wondering. I have another group that says the whole is 10 tenths. I want y'all to think about that. What are they doing with that? Why do they think it's 10 tenths? And what could you model that for them? All right, have you guys been together? And let's go ahead and put those pencils down. Y'all are very innovative with your popsicle sticks. I like that. That was awesome. On showing your model. So the first challenge that I had for you was to explain this problem without using numbers. Was that easy? No. Not at first. It wasn't. Who wants to give us a summary of what's happening here without using numbers? You want to try it? So, are you Caitlin? Just checking. So, Caitlin is saying that we took Josie's part and Margot's part and we put them together, right? And that gave us the whole. But then she said something else. But it's not the real whole. That's something I want us to think about as we talk through this and share our solutions and some solution paths. What does she mean by it's not the real whole? So I'm going to hopefully work this thing the right way. We'll find out in just a second. So it's here, it's not here. Should I? It's always Miss Loveless not knowing how to work the things, y'all. Maybe. All right, so let's take a look at this first solution that I want you to look at. And it is right here. So this first solution here, I want you to see what another group did. I want you to think about what do the green ones represent on either side of there. And why do you think they chose to make the model that way? So turn and talk to your group. What do those green ones represent? Why did they make the model that way?
Represent the breadth of the pen. There's a hole, and the other three is the other half. Okay, so I think that they used the white ones as the tin, as it
Okay, so let's come back together. What do these green ones represent? What do these ones represent?
They represent Josie's and then Margot's.
Josie's and Margot's, right?
Margot, she paints the other side than Josie.
Oh, so they did kind of what the problem said. They both started from either end of the fence, and they painted from one side. I don't understand though. Why are there three in the middle? What's the three in the middle for?
Those are the leftover pieces of fence that I didn't paint yet.
So the leftover pieces of fence that I didn't paint yet. So if I painted the whole fence, how much would I have painted?
One hole.
One whole, or what fraction would I have painted? 10 tenths, right? So they modeled theirs this way, right? So I'm wondering what each of these sticks represent. What do each of those sticks represent? What fraction? Yeah.
Piece of fence.
They do represent a free.
Oh, 1/10.
1/10. And so how do I know it's 1/10?
Because there's 10 sticks.
10 sticks, and the whole is 10. So if we're thinking about that, so you guys told me that we took the parts and we put them together. Did they put their parts together?
No. They separated them.
They
did that so you could see that those were the two parts that were
being painted? Yeah, for sure. So they're actually modeling the problem out, right? So let's take a look at this. So this one, remember we said the whole was 10 tenths.
Yeah.
And that we have those two parts and we put them together and we got 7 tenths, right? But let's take a look at this one. Look at this part whole or number bond that you see here, right? I want you to think about now, what do these numbers represent? And I want you to use the words parts and wholes as you talk to your neighbor. And how is this different from what we just saw? So talk to your neighbors. What's that representing? The two parts came, so what was the whole now? What did they say? What was the model?
And then if you divide it out to the fractions,
True.
each of them,
In the last model, what was the
it
whole?
would be the 10 both because they both do exactly the same thing. So if they didn't get those
Yes, So it's just two different ways to solve the problem. Okay, so let's come back together. So looking at this, what all these fancy lines, what does this mean? What does that mean? Somebody explain. Who wants to share? Here, right here. I haven't heard from you, sweetheart. Talk to me. What does that mean? Didn't set my timer.
I think it's comparing how the numbers. I think this group is taking the whole
Taking the whole.
and then taking Josie's and Margot's and adding them together.
Okay. So Josie and Margot represents parts or wholes? Parts. So these fractions are the parts, and in addition, we do what with the parts? We put them together, right? So these two parts go together to make our whole. But how is this whole different than our last model? Here's our last model. What was the whole here?
10, 10, 10, 10.
And the whole here?
7, 7, 7.
Who's right? Who has the right?
They're both because they were
There's only one way to do math, right?
Mhm.
I think we proved there's not, right? That maybe that if they're right and they're right, there could be two different ways to think about that. So I'm wondering if these are two parts that come together to make a whole, what in the world were they thinking? So I want you to think about that when you look at this next model, okay? So look at this next model here. I mean, obviously there's a model here, but I want you to focus in on this. Do you see this? See what she has there? Her number line. She has, this is in case you can't see, this says 3/10 with a subtraction and 4/10 with a subtraction, and where she ended up. So I want you to talk to your neighbors and make sense of this. How does this connect to these other two models? How does it connect to that one? How does it relate to that one? What's going on here? What did she do? What was her thought process when she decided to make this model to represent the problem? So turn and talk just for a second. Anybody have any thing that they noticed as you were analyzing this strategy before we talk about it? Yeah, what'd you notice?
that they were subtracting the fraction.
They were subtracting, right? And so they started with 10/10. Why did they start with 10/10?
That's the whole.
That was the whole what?
That's what they're starting with.
Oh, wait a minute.
That's the whole.
I thought this was the whole 7/10.
No, that's the answer. That's not that.
That's the answer.
Oh, so she's saying back earlier, what she said is it's not the real whole. But is this the whole? The whole what?
That's not the whole fence. That's just.
It's not the whole fence, but it's the whole what?
That's just what
That they painted.
That they painted. So that's making, remember our learning target for today is to make sense of the problem, and you guys are making sense of the problem. You discovered by this model, this is the hole they painted. With this model, we're not talking about necessarily the hole they painted. We kind of are. But wait a minute. Where is the hole they painted? Where is it?
It's at 10.
It's 10/10 what they painted?
No.
They painted 7/10.
7/10 is what they painted. Where do you see the 7/10?
The third one down from 10.
Okay, I do see 7/10 there. Where do you see the two parts that came together to make
When they
7/10?
subtracted it, when they jumped.
Do you see this jump?
Yes.
I think we jumped, supposedly jumping 3, but we ended up maybe in the wrong spot there, right? So maybe this should have been over just a little to 7 and then jumped back 4 from 7 and landed 3, just off a little bit. Does that happen sometimes when you're making
Yeah,
number
that
lines? And that's okay, because we always make errors and that's okay. But still, is she thinking the right way?
Yes.
Yeah, so she took the whole fence and she took off the what? Use the word parts or holes. What did she take off?
She took off the
The parts, right? The parts that they what?
the painted.
That they painted. So she took the whole fence, she took off the parts that they painted. Remember, we should have landed here at 3/10 because we were off a little. So what does the landing represent? Turn and talk to your neighbor. If I landed at 3/10 after I took off 3 and I took off 4, what does the landing at 3/10 represent? Turn and talk. So, assuming that we had been a little more precise on this, we would have landed at 3/10. What did we say this landing represents? This 3/10? Y'all want to tell me in the back there? What does this 3/10 represent?
The 3/10 represents the parts that were in color.
The part they didn't paint, right? So they took off the parts that they did paint, and they were left with the parts they didn't paint. Did the problem ask us to tell us that?
Nope.
No. But they still were able to take off those parts, and we still can find our 7/10 that they did paint in the jumps, right? So if you're looking at this one, look at this model. Does this model and this representation show us the same thing?
Yes.
Kinda does, doesn't it? Yeah, so we have the 3/10 we took off, there, and the 4/10, and we were left with 3/10. Oh, just in time for that. So when you're thinking about making sense of, so what operation did we use to solve this problem?
Subtraction.
She used subtraction. What some of you use?
Addition.
Addition. So what was the difference in the two ways? I want you to turn and talk at your group. What was the difference and what was the same in the two ways you solved the problem? What the difference? You guys were talking about, which has been our goal for the day, making sense of the problem, right? And you were been able to create models and equations to show me that you did make sense of the problem. So we were talking about in our last little conversation how this one, doing subtraction, was the same as this one, and how it was different. So somebody tell me, summarize for me, how was it the same? How were they the same? Yes?
They were both like adding.
Okay, were they both adding?
No.
Well, no, so if they weren't both adding,
Oh, okay. They're
These
both
were
the
mine.
same because they were both including Margot and Josie.
so both were including Margot and Josie, and in math terms, what are Margot and Josie? They were the what? Characters, and